Let's take a look at simplifying rational expressions. When we simplify rational expressions, we factor the numerator and denominator and cancel out the common factors. Our first example is already in factored form. I have x plus 4 times x minus 3 over x plus 2 times x minus 3. The numerator and denominator both have an x minus 3 that I can cancel out. Our simplified expression is x plus 4 over x plus 2. Our next example is 18x over 24x squared minus 6x. This time, our expression is not factored first. We can leave the 18x in the numerator. In the denominator, notice that 24x squared and 6x are both divisible by 6x. When I factor out a 6x, I'm left with 4x minus 1. We know that 6 goes into 18 3 times, and the x can cancel the x. Our new simplified expression is 3 over 4x minus 1. Next, we have w squared plus 13w plus 22 over w squared plus 7w plus 10. We'll factor the numerator and factor the denominator. When looking at the numerator, we need factors of 22 that add up to 13. That would be 2 times 11. So I have w plus 2 and w plus 11. In the denominator, I need factors of 10 that add up to 7, which would be 2 and 5. So I have w plus 2 and I have w plus 5. We see the w plus 2 as a common factor, which reduces our expression to w plus 11 over w plus 5. Notice that we don't cancel the w's left over in the expression. You can only cancel out factors, you can't cancel out terms, so think you can only cancel when things are being multiplied. Next, I have 4xy plus 8y plus 5x plus 10 over 3x plus 6. In the numerator, I have 4 terms, which makes me think to group the first two and group the second two. When looking at the first two, 4xy and 8y, I see they're both divisible by 4y, which leaves me with x plus 2. When I look at 5x plus 10, I notice they're both divisible by 5. When I divide that out, I get x plus 2. In the denominator, I can divide by 3, which gives me x plus 2. Before you start canceling the x plus 2, we need to do one more step of simplification in the numerator. I have a common x plus 2 to both terms that I factor out. When I factor out the x plus 2, I get 4y plus 5 over 3 times x plus 2. Now I can see a common factor. Again, remember, we only cancel things that are being multiplied. So I cancel x plus 2, I cancel x plus 2, I have 4y plus 5 over 3. Next, I have x minus 2 over 2 minus x. And at first glance, the numerator and denominator look very similar. Let's rewrite it as x minus 2 over negative x plus 2. This way, I have the variable written first in both the numerator and denominator. There's nothing to factor out in the numerator, so I'm going to leave it as x minus 2. But in the denominator, I'm going to take out the negative in front of the x. So I'm going to write that as negative 1. When I factor negative 1 out of negative x, I get x. When I factor out negative 1 out of 2, I get minus 2. This shows me I have a factor of x minus 2 in both the numerator and denominator. When you cancel that out, I don't want you to think that there's nothing left in the numerator. You can put a 1 there. My reduced form, 1 over negative 1, can simply be written as negative 1. We'll do that one more time just to have the practice. I have 3x minus 4 over 4 minus 3x. Like last time, I'll start by writing the denominator as negative 3x plus 4. I'm going to factor out the negative 1 from the denominator. So I have negative 1 times 3x minus 4. Then I can cancel the common factor and put a 1 in the numerator. 1 over negative 1 is negative 1. In general, what we're seeing in the last two examples is that if I have b minus a, I can write it as negative 1 times a minus b. This allows me to reverse the order without losing the equality of the expression.